Okay, I did a bumphead thing there. Just thinking back to what we did earlier. But, again, you have a matrix equation, okay? If you're not 100% sure of what you want to do, you write it out as a system of equations and go from there, okay? So 3 equations and 2 unknowns. What do we know if we get 3 equations? And 2 unknowns. Well, it doesn't guarantee a solution. And our unknowns are C1 and C2. W1, W2, and W3 are arbitrary constants. We're trying to see if there is a solution here, right? Okay? The only way you're going to get a solution is if one of these equations reduces to 0. 0 equals 0, okay? So, solution only if one reduces to 0 equals 0. I've got a piece of popcorn in my throat. Trying to deal with it without doing anything too gross. I could really clear my throat and get rid of that. Okay, anyhow. So there's a solution if and only if one equation reduces to 0, if you do the reduction, okay? Now, we could here's our augmented matrix, right? Can this be reduced to this form? Well, you can just reduce this part of the matrix, right? And see if you end up with at least one row of zeros. Very easy to see, okay? And you see that it's unlikely if the numbers are just randomly selected. But if I selected, well, actually, it's impossible, okay, that you don't get a row of zeros. You might get more than one, but you will get at least one row of zeros, okay? And what I'm really trying to say is, from this part, you're going to get a row of zeros, okay? Doesn't mean you're going to get a 0 here. So I'm saying this all wrong, okay? So I'm going to say maybe but a 0 here is not necessary. And I'm modeling that, you don't necessarily get a 0 here, okay? You do necessarily get at least a row of zeros here, meaning that there are solutions, but there are vectors that aren't solutions, right? And we can get information about those by actually reducing this. So, running out of space here, we still have a little time. So I'm going to do that. Okay, we got 2 - 1 W1, right? Well, that's going to give me 1 - 1/2 W1 over 2. And then we use that here to get 0. And then let's see, we've got to multiply this by negative 1 and add to this. If we multiply this by negative 1, we get 1/2. We multiply this by negative 3 and add to this row. Now I'm combining operations. I don't want you to do that, but hopefully you're good with this. So if we multiply this by 3, we get negative 3/2. Add that to 5, we get 7/2, and we get W2
If you multiply negative
plus
1/2 by negative 3, you get positive 3/2.
Let's see, 5 is 10/2, right?
Yes,
And we're multiplying this by 3.
by negative 3.
Yeah, okay, you get 13/2, don't you? Okay. Thank you. Okay. And down here, we're going to get 0 and negative 1 times that row plus this. I must be getting hungry. I think we get 9/2. And we get W3 plus minus W1 over 2. Okay? And then we can get a 1 here, okay? And use that to get a 0 here and a 0 here. And it's also been 5 hours since I ate that popcorn. I think my blood sugar just dropped. So I don't want to go through with this, but we're going to get a bunch of stuff over here, okay? Make sense? And this is going to be the form of the vectors that we can get, okay? So I'm not going to complete that because it gets a little bit messy. You can check the examples in the book and see how that works, okay? Now the big point I'm making today is you take everything back to definitions, or to simultaneous equations, and use that as a guide for everything else you do, okay? Now I will say here, so we end up here with a column that gives us info about the vectors W that don't appear as combinations of our original set. Should say combinations of vectors in our original set. That's too many words to write. Okay? You know what I mean. I didn't write it exactly right. Okay?